This is a video on speed and acceleration. First learning target is to know what speed is and how to calculate it. Speed is the most basic property of motion. Body travels a certain distance in a given amount of time. Speed is that ratio. The ratio of the distance traveled per the time taken to travel. Equation for speed is equal to distance divided by time. Most of you are probably familiar with miles per hour. That's the same thing as a distance per time. Speed is just a rate, just how rapidly the distance is covered. If you don't know how to use one of the triangles, here's a quick little tip on how to use triangles. If I want to calculate speed is equal to distance divided by time, so I just cover up the S in the triangle, and I have an equation that has distance on the top and time on the bottom. If I want to use a triangle to calculate distance, I just cover up the D, and I have speed times time. And if I want to calculate time, I just cover up the T, and I have an equation that looks like distance over speed. For units on speed, units for distance are going to be in meters, abbreviated with an M. Units for time are going to be seconds, abbreviated with an S, and so I have a unit of a meter per second. Always draw it as a M over an S, not an MPS, but an M with the line underneath it and the S below it. Learning target number 2 is to know the different types of speed. First one to know is average speed. Average speed is what we've been calculating when we use the equation. Generally there's going to be a variation in speed. Sometimes you're going to be going a little bit faster, sometimes a little bit slower. If you take the total distance divided by the total time, that will give you the average speed. Constant speed just means that there's no variation in speed. It means that you're going to travel equal distances in equal amounts of time. An instantaneous speed is the speed that you're going at any given instant, at any given moment. To get instantaneous speed, you're going to need to use a radar gun. Learning target number 3 is to know the difference between velocity and speed. Velocity is just speed and direction. Speed is just the rate. Velocity is the rate and the direction. Now if you have a positive velocity just means that you're moving in the positive direction. In our class we're going to define positive direction as to the right. So anytime you're moving to the right, you have positive velocity. Negative velocity just means you're moving in the negative direction, and for us that's going to be to the left. Positive and negative velocities do not mean that you're speeding up or slowing down. Positive and negative never gives you speeding up or slowing down. Learning target number 4 is to be able to graph and interpret distance versus time graphs. So we're going to talk a lot about graphing motion from here on out in this unit. Remember when we talked about graphing in the first unit, we said that you needed to put the independent variable on the x and you needed to put the dependent variable on the y, and then we said there was an exception. And the exception was that time always goes on the x, no matter if it's the independent or the dependent. And here's the reason why. If you remember from math, slope is equal to rise over run. If you draw a distance versus time graph with time on the x and distance on the y, the slope of that graph now gives you distance divided by time. And distance divided by time is also equal to speed. You also learned in math if A equals B and B equals C, then A must also equal C. So if the slope is equal to the distance over the time, and the distance over the time is equal to the speed, then the slope must be equal to the speed. So on a distance versus time graph, the slope of the line is equal to the speed. The steeper the slope, the faster the speed. So if I have two objects, A and B, A is going to be going faster than B because it has a steeper slope. It covers the same distance in a much quicker amount of time. So A is a fast speed and B is a slow speed. This is where things get a little bit trickier. Talk about negative distances and negative velocities and negative accelerations. Don't think in terms of math. In math, a -2 is less than a +2, but in science, that's not the same thing. In science, +2 and -2 in this case are the same distances away. It's just that +2 is to the right and -2 is to the left of the 0 point. So anything on the bottom half of the graph just means that I am to the left of the start point, and anything on the top of the graph just means that I am to the right of the start point or the 0 point. Learning target number 5 is to know what acceleration means and be able to calculate it. Now, when we talk about motion, there's two different ways to change motion. You can change the motion of an object by changing its speed or by changing its direction. In science, if you change speed or direction, we call that acceleration. So in the real world, we might say that you only accelerate if you speed up, but in science, there are a couple of different ways that you can accelerate. You can accelerate by speeding up, or you can accelerate by slowing down, because that still is a change in velocity. And then the third way is to change direction. Velocity is speed and direction. So if you change direction, you've changed velocity. And if you change velocity, you've accelerated. So even if you maintain a constant speed, if you change direction, you're technically accelerating in science. Given two different cars, station wagon and Corvette. Two people are at a stoplight. One person's in a Corvette, one person's in a station wagon. If the light turns green and both cars take off, both cars are capable of going from 0 to 60. But the Corvette is going to accelerate faster because it gets to that 60 miles an hour quicker in less time than the station wagon does. So even though acceleration is technically any change in velocity, when we calculate acceleration, we have to consider how long it takes to make that change in velocity. So again, acceleration is going to be the rate of change of velocity. So when we go to calculate it, we calculate it as the change in velocity divided by the time. When we talk about change in velocity, make sure that you take the final velocity, subtract off the initial velocity. So if you go from 0 to 60, you end up with a positive number and positive acceleration. A lot of times we'll abbreviate v sub f for final velocity, v sub I for initial velocity, and then the t for time. So acceleration is v sub f minus v sub I divided by t. Once in a while you'll see delta v for v sub f minus v sub I. Delta v just means a change in v. Now units on acceleration. The units for velocity are going to be in meters per second, and the units for time are going to be in seconds. So what I end up with is a meter per second. And the fancy math will give you a meter per second squared. If you want to understand the fancy math, here it is. I can divide that second on the bottom by 1. Doesn't change anything. I can multiply the top and the bottom by the same number, essentially multiplying by 1, and I don't change anything. Now my seconds on the bottom cancel. I'm left with a meter over a second times a second, and a meter times over a second times a second is the same thing as a meter per second squared. So what you really need to know is that meter per second is a velocity, meter per second squared is an acceleration. Okay, now the second type of graph that we're going to have to deal with is a velocity time graph. We're still back to the same math equation for slope. That's rise over run. In the velocity versus time graph, the slope really is the change in speed divided by the time. We've also defined acceleration as a change in speed over time. So once again, on a velocity time graph, the slope is equal to acceleration. So if I have two objects, A and B, the A has a much steeper slope, so it has a much greater acceleration than the B line does. So the A line would represent the Corvette, which gets to its 60 miles an hour really, really quickly. The B would be the station wagon, which gets to its 60 miles an hour really, really slowly. On a velocity time graph, we've said that the slope is equal to acceleration. Anytime you end up with a positive slope, we call that positive acceleration. Anytime you end up with a negative slope, we call that negative acceleration. Now, positive and negative, again, just indicate direction. Positive and negative do not indicate speeding up or slowing down. If you have no slope, that just means that you have no acceleration. It means you're going at a constant speed. So in this particular example of this graph, if I have a positive slope, that's positive acceleration. If I have no slope, that's a constant speed. If I have a negative slope, we call that negative acceleration. And anytime your velocity is 0, that means that you are at rest, you are stopped. Now, to understand the speeding up and slowing down, again, we need to think hard about what negative velocity means. Okay. Negative velocity just means that you're moving to the left. Now, to figure out if you're speeding up or slowing down, you need to think about if you're getting closer to 0 velocity or further away from 0 velocity. In this particular case, we're getting further away from 0 velocity. So again, don't think in terms of math. Negative numbers don't mean less. They just mean that you're going in a different direction. So when I go from 0 to -2, my speedometer is actually getting bigger. I'm going from 0 to 2 on the speedometer. The negative just means I'm going to the left. So in this case, I'm speeding up. Okay. If I have a positive velocity, it means I'm moving to the right. And again, since my numbers are getting further away from 0, that means that my speedometer is going up, which means I am speeding up. To show something slowing down, that means I'm getting closer to 0 velocity. So here I'm slowing down, but because I'm above the 0 line, it means I'm slowing down going to the right. Here, I'm getting closer to 0, so again I'm slowing down. Since I'm on the negative side, it just means I'm slowing down as I go to the left. So here I have a velocity that's getting less, closer to 0, it means I'm slowing down. Negative acceleration, negative slope. Now when I hit the 0, it means that I'm at rest. If I continue with this negative acceleration, okay, I'm going to continue to have a negative slope. But after I cross over this line, it means that I have gone to the left. So I started out slowing down. I stopped. And now, when I got below the line, I've changed direction. Since my numbers are getting bigger, I've changed direction and I've started to speed up. So, quick handy little tool. If my velocity is in the positive direction and I have a positive slope, that means I'm speeding up. If I have a positive velocity and my acceleration is negative, that means I am slowing down. If I'm on the other side and I have a negative velocity and a negative acceleration, I'm speeding up. I'm getting further and further away from 0. If I have a negative velocity and a positive slope on my acceleration, that means I'm slowing down. I'm getting closer to 0 velocity. You can use distance versus time graphs to show acceleration as well. Here I start with a very, very low slope, which means a slow speed, and I get to a much steeper slope, a fast speed. So I've gone from slow to fast, which means I am speeding up. To show slowing down, I start with a steep slope, meaning I'm going fast, and I gradually get to a lower slope, which means I am slowing down.